In this lecture, we are going to talk about the z-test. We have already seen that if we have the statistic S available with respect to the sample, we can calculate the normal variate Z using the formula Z is equals to S minus mu S over sigma S. Based on this, we are going to predict the parameter of the population, and the parameters which we usually predict are the population mean and the population proportion, or the difference in means or difference in proportion of two samples. So for that we will be formulating a null hypothesis and an alternate hypothesis. So the null hypothesis will always be the parameter is equals to some constant k, and the alternate hypothesis would be parameter is either less than k, greater than k, or not equals to k. So based on these inequalities and not equals to, they are classified as left tail test, right tail test, and two tail test. So we are going to consider the Z test based on the alternate hypothesis. So the alternate hypothesis, if it reads parameter is less than k, then we will be finding the Z score, and we will be looking at whether Z belongs to this rejection region. For a left tail test, anything below ZC, that is Z less than minus ZC, it will be classified as a rejection region. So if Z belongs to this rejection region, then we are going to reject the hypothesis, null hypothesis. And for a right tailed test, the alternate hypothesis is the parameter is greater than k, and anything greater than ZC would be rejected. And for a two tailed test, the parameter is not equal to k, then anything greater than ZC or anything less than minus ZC will be rejected. So we have two levels of significance usually. One is 5% and 1%. At 5% level of significance, for a left tail test, minus ZC is minus 1.65. So anything below minus 1.65 will be rejected. For the right tail test, anything above 1.65 will be rejected. For a two tail test, anything above 1.96 or anything below minus 1.96 will be rejected. Similarly, at 1%, we already know that ZC minus ZC is minus 2.33, ZC is 2.33, and for a two tail test, it is 2.58 and minus 2.58. So now let us consider problems based on these things. Here they are asking you to compute the value of the test statistic for the indicated test based on the information given to us. So the first problem, the null hypothesis is mu is equals to 342, and the alternate hypothesis is mu is less than 342. So this is a left tailed test. Sigma is given as 11.2, n is equals to 40, and x bar is 339, s is 10.3. So the z is given as x bar minus mu over sigma over root n, which is equals to 339 minus 342 over 11.2 divided by square root of 40, which is equals to minus 1.69. So for the second case, we have mu is equals to 105, and the alternate hypothesis is mu greater than 105. So this is a right tailed test. Sigma is given as 5.3, n is 80, x bar is 107, s is 5.1. So over the normal variate z is x bar, which is 107 minus mu 105 over sigma is 5.3 divided by root 80, which is 3.38. So in this problem they just asked you to calculate the z-score, that's all, the statistic. Okay, so the next problem reads, compute the value of the test statistic for n is equals to 55, x bar 75.1, s is 9.25, sigma unknown, and test the hypothesis h naught is mu is 72.2 against ha is mu greater than 72.2. So this is a right-tailed test. They are asking us to test at both 5% and 1% level of significance. So z is 75.1 minus mu is 72.2 divided by s 9.25 divided by root 55. So since here sigma is not given, we will be considering the sample standard deviation, which is s. So this is given by 2.33. At 5% level of significance, ZC is equals to 1.65. So here the rejection criteria is anything right tail test, anything greater than or equals to ZC should be rejected. So here you can see that 2.33 is greater than ZC. So we are going to reject the hypothesis at 5% level of significance. At 1% level of significance, ZC is 2.33 and 2.33 is greater than or equals to, in fact here it is equals to ZC. So we are going to reject the hypothesis. So anything greater than or equal to ZC needs to be rejected. So that's it. Next, the next problem. Perform the null hypothesis perform the hypothesis test given h naught is mu equals to 212, mu is less than 212. So this is a left tailed test at 5% and 1% level of significance. Sigma is unknown, n is 36, x bar is 211.2 and s is 2.2. So where z will be equals to x bar minus mu x bar over sigma x bar, which is x bar minus mu over, since sigma is unknown, we can use s over root n, which is 211.2 minus 212 over 2.2 divided by root 36. This is obtained to be equals to minus 2.18. At 5% level of significance, so this is a left tail test, so we need to know what is minus ZC. At 5% level of significance, minus ZC is minus 1.65 and minus 2.18 is less than minus 1.65. So here we are going to reject the hypothesis at 5% level of significance. At 1% level of significance, minus ZC is minus 2.33 and minus 2.18, it is not less than minus 2.33. So we will not reject the hypothesis because it is this value, it is falling in the confidence interval. So this is minus 2.33 and your minus 2.18 will be here. So we want anything in this region. Okay, so therefore we do not reject the hypothesis at 1% level of significance. So all these problems were related with the testing the hypothesis for the population mean. Yes. The next problem is a cosmetic company fills its best-selling 8-ounce jars of facial cream by an automatic dispensing machine. The machine is set to dispense a mean of 8.1 ounce. So mu is equal to 8.1 with a standard deviation of the amount dispensed as 0.22. So sigma is 0.22. A quality control engineer routinely selects 30 jars. So n is equals to 30 from the assembly line to check the amounts filled. On one occasion, the sample mean is found to be equal to 8.2 ounce and the sample standard deviation S is found to be equals to 0.25 ounce. Determine if there is sufficient evidence in the sample to indicate at 1% level of significance, that the machine should be recalibrated. So that means if the mean is not equals to 8.1, we need to, if it is greater than or if it is less than 8.1, we need to recalibrate it. That's what it means to say. Okay, so here the null hypothesis will be mu is equals to 8.1. The alternate hypothesis will be mu not equals to 8.1. So this is a two-tailed test. So let us find z. So z is equals to x bar minus mu divided by sigma, because sigma is given. Even though s is also given, we will not use this, right, because sigma is already given. Suppose if sigma is not given, then we will, whatever is available for us, we will consider that in the formula. So here it would be 0.22 divided by root of 30, and it is found to be equals to 2.49. So here they are asking only at 1% level of significance. Okay, so here at 1% level of significance, it is a two-tailed test. ZC is equals to 2.58, and if we compare 2.49, so here we expect something to be beyond 2.58 and before minus 2.58. Okay, so 2.59 is not greater than, it's not greater than or equals to 2.58. So we will not reject. So do not reject. So do not reject the null hypothesis. What does the null hypothesis say? Null hypothesis says that the mean is equals to 8.1. So that means do not reject means we are going to accept the hypothesis. We are going to, that means accept the null hypothesis. So that means to say that we need not recalibrate. Need not recalibrate. That is, the machine does not need to be recalibrated. Okay. So next we will move on to the next problem. So these first four problems were all with respect to the population mean. Next here comes something related with the population proportion. So as I said you in the previous class also, if the mean and standard deviation is given, we are testing the hypothesis for the mean of the population. If the mean standard deviation is not given, average is not given, we will be doing for the proportion. So okay, in a random sample of 125 cola drinkers, so n is equals to 125, 68 said they preferred Coke over Pepsi. Okay, so 68 out of how many? 125. So that will be the proportion of success in the sample. They said that they prefer Coke over Pepsi. Let P denote the percentage of all cola drinkers that prefer Coke over Pepsi. That is for the entire population. Do a Z test to the null hypothesis. H naught is P equals to 0.5 against P greater than 0.5. So P greater than means it is a right-tailed test at 0.05 level of significance. So now our Z will be equals to capital P minus mu P over sigma P, which is given as capital P minus small p, because mu P is equals to P over square root of P Q small p Q divided by N. So this will be 68 by 125, it is approximately 0.544. So this would be 0.544 minus 0.5 over square root of 0.5, Q will be 0.5 divided by 125. It's found to be equals to 0.98. It's found equal to 0.98. So it is a right-tailed test. It is a right-tailed test. So we need the ZC at 5% level of significance. ZC is equals to 1.65. And 0.98 is not greater than 1.65. So 0.98 will be somewhere here, and this is 1.65. Certainly 0.98 is not greater than 1.65. So here we do not reject the hypothesis, the null hypothesis. So this was a problem with respect to the proportion. Next, let P denote, so they have only given the proportion, denote the proportion of the students at a private college receiving some sort of financial aid. Suppose a null hypothesis and alternate hypothesis are H naught is P equals to 0.5 and HA is P greater than 0.5. So this is again a right-tailed test. How large a sample is needed? So that means we need to find what is N. For the sample proportion, P equals to 0.68 to be statistically significant at, so this is capital P. Capital P is given 0.68, small p is 0.5. So we need to find what is the N, how large a sample size must be, we need to find it. Okay, so Z is equals to capital P minus P over square root of PQ over N. So we need to find the N. So statistically significant means your Z should be greater than, so for a at 0.01 level of significance, it is a right-tailed test. So ZC is equals to 2.33. So at 0.01 level of significance, anything greater than 2.33, we are going to reject. So we need this to be greater than or equals to 2.33. So let us substitute all the values given. Capital P 0.68 minus 0.5 divided by root of 0.5 into 0.5 divided by N to be greater than or equals to 2.33. So this implies, after the simplification, 0.36 root N to be greater than or equal to 2.33, or N is found to be greater than or equal to 41.89, or N greater than or equals to 42. So if the sample size is greater than or equals to 42, so we can say that the capital P 0.68 is statistically significant at 0.01 level of significance. Okay, so the next problem is a builder claims that the heat pumps are installed in 70% of all homes. So it is a percentage. So probably it will be the, not probably, it is proportion only, 0.7. In a city, would you agree with the claim if a random survey of new homes in this city showed that 8 out of 15, so that will be your proportion of success in the sample, had heat pumps installed at 0.05 and 0.01 level of significance. So here from this itself you can see that N is equals to 15. Okay, so the sample they have chosen is 15, and out of 15, 8 have installed the heat pumps. So let us frame the hypothesis. H naught is, of course, P is equals to 0.7. So here they do not tell whether increased or larger than or lesser than or decreased. So the alternate hypothesis will be P not equals to 0.7. So if the proportion of the population which has installed the heat pumps is not 0.7, then we can reject or accept the hypothesis. So let us write the Z. So Z will be equals to capital P, or it is 0.5333 minus small p, which is 0.7 over square root of P 0.7 into Q will be 0.3 divided by 15, and this is found to be equals to minus 1.41. So at 5% level of significance, so this is a two-tailed test. It is a two-tailed test. So ZC, we need both minus ZC and ZC. So here we can see that at 5% level of significance, minus ZC is minus 1.96 and ZC is 1.96, and here this is minus 1.96 and this is 1.96, and your minus 1.41 would be here. So the critical region is minus infinity to minus 1.96 and 1.96 to infinity. So certainly your minus 1.41 does not belong to the critical region. So that means we do not reject the hypothesis. Do not reject. Then at 1% level of significance, minus ZC is minus 2.58 and ZC is 2.58, and the critical region is minus infinity to minus 2.58 and 2.58 to infinity. So again this minus 1.41, it is not belonging to the critical region. So if suppose this is minus 2.58 minus 1.41 is here, so it does not belong. So again we are not rejecting the hypothesis. So do not reject the hypothesis. So here we are neither at 5% nor at 1% we are rejecting the hypothesis. So these problems were with respect to the proportion, okay, testing the hypothesis for the proportion of success in the population. So next we will consider difference in means and difference in proportions. So how do you know whether it is difference in means or difference is proportions? Again, as I said you, if it is an average or mean or standard deviation, it is a testing the hypothesis for means. And if we have two populations, certainly it will be difference of the means. And similarly for the proportions. So whenever we have two samples, then we can go for either difference in means or difference in proportions. Okay. In order to make a survey of the buying habits, two markets A and B are chosen at two different parts of a city. 400 women at random in market A. So in market A, 400 women are chosen. So that will be N1. And the average daily expenditure on food is found to be rupees 241. So this is the sample mean. So x1 bar is equals to 250 with a standard deviation of S1 is equals to 40. Okay, the figures are rupees 220, that is x2 bar is equal to 220 and S2 is equals to 55 respectively in the market B, where also 400 women were chosen. So N2 is also equals to 400. They are asking us to test at 1% level of significance whether the daily average food expenditure of the two populations of shoppers are equal. That means the population mean. The population mean is mu1 for the first population and mu2 for the second population. They are asking us to check whether they are equal. That is mu1 is equals to mu2. So our null hypothesis will be mu1 minus mu2 is equals to 0. Remember that whatever parameter we are checking, that should always be equated to some constant. And HA will be mu1 minus mu2 not equals to 0. So this is a two-tailed test. So let us, the statistic Z is given by x1 bar minus x2 bar minus of mu x1 bar minus x2 bar over sigma x1 bar minus x2 bar. And your mu x1 bar minus x2 bar is given by mu1 minus mu2, which in this case it is equals to 0. Sigma x1 bar minus x2 bar, it is given by square root of sigma 1 square over n1 plus sigma 2 square over n2. Since here the population standard deviation is not given, we can go for the sample standard deviation plus h2 square over n2, so which is equals to square root of 40 square over 400 plus 55 square over 400, which is found to be equals to 3.40. So substituting in this z, we will have x1 bar is 250 minus 220 minus 0 divided by 3.4, and it is found to be equals to 8.82. So at 1% level of significance, the ZC value is equals to 2.58, and minus ZC is minus 2.58. ZC is equals to 2.58, and the critical region is minus infinity to minus 2.58 and 2.58 to infinity. So this is the critical region, this is minus ZC and this is ZC. So anything in here, and we have obtained 3.4, so this is 2.58, so 3.4 will be somewhere here. So 3.4, sorry, 8.82, certainly it belongs to the critical region. So therefore we are going to reject the hypothesis. What are we going to reject the hypothesis? The null hypothesis, which is the population means are equal. So reject means the population means are not equal. So this was a problem based on differences of means. So then final one problem we will have, wherein we will be having the differences of proportions. The statement reads like this: in an exit poll inquiry, it was revealed that 600 voters in one locality. So we see, looking at the sentence itself, we can say whether it is a single population or a two population, right? In one locality and 400 in another locality favored 55%. So this is not mean, this is percentage. That means it is a probability. So it is a probability or the proportion of success. So this one will be capital P1 is equals to 0.55, capital P2 is equals to 0.48. Respectively a particular party to come to power. Test the hypothesis that there is a difference in the locality in support of the opinion. That means the proportion, that means proportion of success in the populations P1 and P2. So they are not equal, so differs. So that again here it is a two-tailed test. So let us write the null hypothesis. Null hypothesis is P1 minus P2 is equals to 0. Then the alternate hypothesis will be P1 minus P2 not equals to 0. So this is a two-tailed test. Since they have not mentioned at what percentage, we will go for both of them. So here Z will be given by P1 minus P2 minus mu of P1 minus P2 over sigma of P1 minus of P2, wherein mu of P1 minus P2 it is given by small p1 minus small p2. Here it is equals to 0. Sigma of P1 minus P2 it is given by square root of P1 Q1 divided by N1 plus P2 Q2 divided by N2. Since here the population proportions we do not know, we can take whatever is available for us divided by N1 plus P2 into 1 minus P2 divided by N2, which is substituting the values 0.55 into 0.45 divided by 600 plus 0.48 into 0.52 divided by 400, which is found to be equals to 0.0322, and Z is P1 minus P2, 0.55 minus 0.48 minus 0 divided by 0.0322, and this is found to be equals to 2.17. So at 5% level of significance, and this is a two-tailed test, so minus ZC is equals to minus 1.96 and ZC is equals to 1.96. The 2.17, so this is minus 1.96 and 1.96, this is 2.17, right? So this belongs to the critical region. So therefore we are going to reject the hypothesis at 5% level of significance. At 1% level of significance, minus ZC is minus 2.58 and ZC is 2.58 and 2.17. So here it is minus 2.58, 2.58, but 2.17 will be somewhere here. So 2.17 does not belong to the critical region. So therefore we do not reject the hypothesis at 1% level of significance. So this was all about the Z test involving means and proportion, difference of mean and difference of proportion.